Hello everyone, welcome to memoneet. So I am Aprajita, your chemistry SME. Welcome back to another video solution. So students, today we are going to discuss the video solutions for your BPT 14. So the chapter that came up in this test was P block. So I hope all of you performed well there and scored good marks. So today we are going to discuss the solutions for that. Okay, so this P block we have covered it from both the classes 11th and 12th, means from group 13 to group 18 all the things have been covered. Okay, so let us start with the first question, which is question number 51. Among the following, which one is a wrong statement? So first is pH5 and BiCl5 do not exist. Now if I talk about pH5 and BiCl5, so phosphorus and bismuth, they have to extend the octet. Okay, hydrogen and chlorine don't have sufficient electronegativity to excite electrons to vacant d orbitals. Okay, so that is why the octet cannot be expanded. So pH5 and BiCl5 do not exist because the overlapping of orbitals is not stable. So it's actually a correct statement. P pi D pi bonds are present in sulfur dioxide. So you know sulfur dioxide is sp2 hybridized and one lone pair is there. So the two pi bonds with the two oxygen atoms, they form p pi and p pi D pi bonds. This is also correct. SeF4 and CH4 have same shape. So if I talk about this, CH4, that is your methane, has 4 bond pairs and no lone pair and it's tetrahedral, while SeF4 has 4 bond pair and 1 lone pair. So because of that it has a seesaw shape. So they are not having same shape. This is a wrong statement. I3 plus has bent geometry. So in I3 plus, due to 2 lone pair of electrons and 2 bond pairs on the central atom, it has a bent shape. So this is also correct. So the incorrect statement is the second one, that the third one, sorry, that is ACF4 and CH4 have same shape. This is wrong. Now question number 52, strong reducing behavior of H3PO2 is due to. So now if we talk about the H3PO2 structure, so it is having like this. So there is one double bond oxygen, then OH and H. So this H3PO2, the strong behavior, it is because of the presence of one OH group and two phosphorus hydrogen bonds. So because of the two phosphorus hydrogen bonds and present of one OH group, it shows a strong reducing behavior. So the answer is option number 1. Okay, next. Given below are two statements. So statement 1 says alpha and beta forms of sulfur can change reversibly between themselves with slow heating or slow cooling. And statement 2 is at room temperature the stable crystalline form of sulfur is monoclinic sulfur. So yes students, in this question what happens is, yes, alpha and beta form of sulfur, they can change reversibly with slow heating or slow cooling. Yes, they can interconvert to each other, all right. But if I, so this statement is true, but if I talk about the second statement, so at room temperature the stable crystalline form of sulfur is the rhombic sulfur. Okay, this is about the allotropes of sulfur we are talking about. So at room temperature sulfur, that is the rhombic sulfur, is the most stable form, not the monoclinic. So this is wrong. It means that the first statement is true but second is false. The answer is option 3. Next question number 54. So there are the names of some processes given here. We need to match them with their application. So you know that Haber's process is used for the synthesis of ammonia, where hydrogen and nitrogen gas combine together to form ammonia. So that's Haber's process. Okay, so for A it's 3. Now Ostwald's process, it is used for the synthesis of nitric acid. In contact process sulfuric acid synthesis happens. Okay, and Hall-Herold's process, it is actually coming under a metallurgical process. So it is used in the extraction of aluminium. Okay, So it's one of your metallurgical process. So A3, B1, C4 and D2, the answer is option number 3. Okay. Next up is question number 55. A group 15 element metal forms a hydride with strongest reducing power among group 15 hydrides. So that one is. So if I talk about group 15 elements, we have nitrogen and phosphorus, which are non-metals. Arsenic and antimony are metalloids, and bismuth is a metal. So these are the hydrides that are formed. Okay, so we have to tell the hydride with strongest reducing power which at metal will be forming. Now, if I talk about ammonia, so in ammonia, nitrogen is more electronegative than hydrogen. So the hydrogen atoms, they get a partial positive charge because of less electronegativity. But if I talk about bismuth, here the metal is more electropositive, right? So hydrogen will be more electronegative. It will be having partial negative charge, and bismuth has partial positive charge. So BiH3 is a stronger reducing agent because here H plus is a strong reducing, H minus is a strong reducing agent. So the answer for this question is going to be option number 4, that is bismuth. So again, which one of the following group 15 hydride is the strongest reducing agent? Just now we have seen here bismuth hydride BiH3 will be the strongest reducing agent. Alright, now moving on to the next question, students. Which one of the following compounds of group 14 elements is not known? Okay. So if I talk about group 14 elements, in this case SiCl4 2 negative does not exist because of the steric crowding of surrounding atom, because chlorine, now silicon is not that big, okay, and chloride ions are large in size. So 6 here if we are having 6 or 4 whatever it is, so 6 chloride ions cannot be accommodated around Si4 plus, okay. It has to be 6, right? So instead of 4, write 6 here, students, okay? Because again here, that's why silicon will be having 4 plus charge. So 6 chloride ions, which are big in size, they cannot be accommodated around one silicon due to the limitation of its size. And interaction between the lone pair of chloride and silicon ion is not very strong. So SiCl6 2 minus will not exist. Okay, answer is option 3. Okay, question number 58. The incorrect statement is, okay. So chlorine is more reactive than ClF. Now, if I talk about the interhalogen compounds, so it's an interhalogen compound between chlorine and fluorine. All right. So students, this statement is actually not true because chlorine is less reactive than the interhalogen compound ClF, okay, and fluorine is more reactive than ClF. This is true, okay, so fluorine will be more reactive. On hydrolysis, ClF forms HOCl, so yes, if we add water to it, it will form HOCl plus HF, and fluorine is a strong oxidizing agent than chlorine. This is also true because the oxidizing power, it goes on decreasing from fluorine to iodine. So all these statements are true. Answer is option number 1, which is an incorrect statement. Okay. Next is question number 59. Chalcogen group elements are. So you know that group 16th elements, that is the oxygen family, they are known as the chalcogen. So we have oxygen, sulfur, selenium, tellurium and polonium in this group. So selenium, tellurium and polonium, answer is option number 2. Okay, now the next question is question number 60 about the oxides. So oxides are given, we need to tell their nature. So students, you know that the metallic oxides, they are generally basic in nature because they can donate the electrons. Whereas if I talk about the non-metallic oxides, so they are acidic in nature as they can accept electrons. So carbon monoxide, it's actually a neutral oxide. Barium oxide, it's a metal oxide, so it will be a basic oxide. Aluminium, now this aluminium oxide, it's actually amphoteric. Now what does amphoteric means? Amphoteric oxides are the ones which can show acidic character as well as the basic character. Okay, so it's amphoteric in nature. And your chlorine, Cl2O7, it is a non-metallic oxide, so it will be acidic in nature. Okay, so yeah, the answer is going to be option number 1, A2B1, A2B1, C4D3. Yes. Next is question number 67. In polythionic acid H2SO6, X can be up to 3 to 5. The oxidation state of sulfur R. Okay. So students, if I talk about the oxidation state of sulfur, so students, it's actually S2SXO6. Okay, this is the correct formula where X can be from 3 to 5. And if I talk about the oxidation state of sulfur, so the central sulfur atom which is attached to the other two sulfur, so its oxidation state is going to be 0. And for the other sulfur, so on one hand it is attached with OH, and then there are two double bonds with oxygen, so its oxidation state is +5. So it means the oxidation state are 0 and +5. Okay, so answer is option 4. Next, the number of S double bond O present in sulfurous acid, peroxodisulfuric acid and pyrosulfuric acid are. So students, first of all, you need to know the formulas of these acids because the names are given. Okay, so sulfurous acid is H2SO3, and in H2SO3 you have one sulfur and oxygen double bond. In peroxodisulfuric acid, there are 4 sulfur oxygen double bonds. Okay, H2S2O7, that is the formula. Okay, 8. All right. So H2S2O8 is there, and there are 4 sulfur oxygen double bonds. And if I talk about the pyrosulfuric acid, this one is H2S2 and O7. Okay. So yeah, in this case also we are having 4 sulfur oxygen double bonds. So if you know the structures as well as the names, you can clearly answer this question. So it's 1, 4 and 4. The answer is option number 4. Okay. Next up, question number 63. So the number of bonds between sulfur and oxygen atoms in S2O8 to negative, and the number of bonds between sulfur and sulfur atoms in rhombic sulfur are. Okay, so S2O8 minus. Now here there are 8 bonds that are present between sulfur and oxygen. Okay, you can see here, although there are double bonds as well, but if I count how many linkages are there, so you can say 1, 2, 3, 4, 5, 6, 7, 8. 8 linkages are there, and rhombic sulfur is like this. Okay, like a W shaped, S8. Okay, so it is S8, and so you can say that how many 8 bonds are present. 7, 8. 8 bonds are present. So answer is going to be option number 3, 8 and 8. Okay. Question number 64. The number of possible oxidation states of p block elements. So we have to tell about the oxidation state. So the number of possible oxidation states increases. Okay. Towards the right of the periodic table. Now what happens, so they will be increasing because increase in the number of valence electron it happens. Okay, which allows these elements to exhibit a greater variety of oxidation state. So elements in higher groups, they have more oxidation state because they can use their all electrons for the bonding. All right. So it means we can say that the number of possible oxidation state of p block elements increases towards the right of periodic table. Now question number 65. The compounds formed by highly reactive non-metals with highly reactive metals and with the non-metals are respectively. So students, you know ki if there are non-metals that are reacting with your highly reactive metals, so there will be a transfer of electrons. Okay, transfer of electrons because of the large electronegativity difference, so they will be forming ionic compounds. Whereas if I talk about highly reactive non-metals, they will be forming covalent compounds with other non-metals because there will be small difference in the electronegativity. So in that case, transfer of electrons would not be possible and there will be sharing of electrons. Okay, so it means the answer is going to be ionic and covalent, option number 2. Okay, now question number 66. Third period elements of p block with electronic configuration 3s2 3pn have vacant 3d orbitals, and those 3d orbitals, they lie between which energy level? So I hope you know about the energy levels, right? So if I talk about the energy level, so it's 1s, then 2s, 2p, 3s, 3p, all right, then 3d and 4s. Okay, so it means obviously the 4s orbitals, they get filled before the 3d orbitals, but the energy of the 3d orbitals lies between 3p and 4s. Okay, so 3p and 4s ke beech mein it will lie. So yeah, the answer is option number 1. All right, now next question. Correct order of atomic radii in group 13 elements is. Okay, so we know students that once we are moving down the group, the atomic radii or atomic size, it increases. Okay, because there is successive addition of one extra shell of electrons. But if I talk about one case, now there is one anomaly, there is exception, which is gallium and aluminium. Of course, if we are moving down the group, so the order should be boron, aluminium, gallium, indium and thallium, right? But if we talk about aluminium and gallium, now gallium has this configuration argon 3d10 4s2 4p1. It has extra d electrons. Okay, and on moving down the group, the atomic radius of gallium is slightly lower. It should be more than that of aluminium, but it is slightly lower than that of aluminium. It is because that there are d electrons. So these d electrons, they do not shield the nucleus effectively. As a result, the electrons that are present in gallium, they experience greater force of attraction by the nucleus than in aluminium. So the atomic radius of gallium is known as 135 picometer, and it is slightly less than that of aluminium, which is 143 picometer. So that is going to be the order: boron, gallium, then aluminium, then indium and then thallium. So we call it as lanthanide contractions as well. Okay, all right. So in lanthanide and actinide contraction, there are 4f and 5f. Similarly to similar to that way here, because of d electrons, the atomic radii is less. Okay, so you must know about the exceptions also. Now next question, between which of the following elements is the discontinuity in ionization enthalpy values observed? Again, now if I talk about the ionization enthalpy, it is the energy required to remove the most loosely bound electron from the isolated gaseous atom. And if we talk about the general trend, so ionization enthalpy actually decreases down the group. Now why it decreases down the group? Because the size of the atom increases and the outermost electrons move away from the nucleus. So lesser energy is required to remove the electrons. Okay, so but again it is not smooth. There are certain discontinuities that can be seen. Okay, so again, if I go from boron to aluminium, it is going to decrease. But when we move from aluminium to gallium, again there is a discontinuity in the ionization enthalpy value. Okay, and then if we move from indium to thallium, it is because of like instead of decreasing, it would slightly increase, again because of the poor shielding effect of the D and the F electrons. Okay, so they have low screening effect. So in that case, the ionization enthalpy, instead of decreasing, it increases because the outer electrons are tightly held by the nucleus. So that's the thing. Okay, so it means that the discontinuity can be seen in indium and thallium, and this aluminium and gallium also, means both 1 and 2 are correct. Okay, now next question, question number 69. The electronegativity of aluminium is similar to lithium, carbon, beryllium or boron. So students, you might have heard of diagonal relationships. Okay, diagonal relationship between the elements of period 2 and period 3. So they will have similar properties. Now beryllium and aluminium, they show diagonal relationship which is based on their same Z effective upon R values. Okay, like if we take this ratio, Z effective means your effective nuclear charge and atomic radius. So diagonal relationship में the elements have similar properties. So for aluminium, it shows diagonal relationship with beryllium. So yes, like if I talk about magnesium, it will show diagonal relationship with lithium. Okay, so yes, for this question, the answer is option number 3, that is beryllium. Now moving on to next question, 70. Relative stability of +1 oxidation state of group 13 elements, follow the order. Now if I talk about the group 1 and +1 and +3 oxidation state, so the order is going to be, now for +1 oxidation state, the stability increases from boron to aluminium to gallium, indium and thallium. But the stability of +3 oxidation state, it decreases. So students, you can observe that the stability of higher oxidation state, it is decreasing down the group, but stability of lower oxidation state is increasing. This is because of the inert pair effect. Okay, inert pair effect means the inability of the S electrons to participate in the bonding. So the inert S electrons, if they will not participate in the bonding when we are moving down the group, so what happens is the ability of that particular element to show higher oxidation state, means +3 oxidation state, will decrease. So it is decreasing because of inert pair effect. So they can ask you any order, +1 or +3. In the question they have asked about +1 oxidation state. So it is increasing from aluminium to gallium to indium to thallium. So yes, the answer is going to be option number 2. Now question number 71. In a trivalent state, the number of electrons around the central atom in the molecule of a compound of group 3 elements would be. Now if I am talking about trivalent state, means the valency is 3. Okay, because group 13 elements already have 3 electrons in their valence shell. If they have 3 electrons in their valence shell, means they can share only 3 electrons. If they can share 3 electrons, 3 already they are having, so it means that the number of electrons around the central atom is going to be 6. Okay, so they will be having 6 electrons. So the answer is option number 2, that is 6. Next question, students, question number 72. The small increase in covalent radii from silicon to lead is due to the presence of, now we are talking about the so there is a considerable increase in covalent radius from carbon to silicon. Okay, then from silicon to lead there is only a small increase in radius. Now it is because of the presence of completely filled d and f orbitals in the heavier members. Okay, so because of completely filled d and f orbitals in the member, so you know there will be poor shielding effect. Okay, because of poor shielding, the nuclear charge will be more, and if the nuclear charge is more, the increase in the atomic radii would be less. Okay, it will not be that much. So the answer is option number 2. Now next question, which of the following is the correct order of first ionization enthalpy of group 14 elements? Now again, if we are moving down the group, the ionization enthalpy, it decreases. Okay, group 14 elements, oxygen, if I talk about silicon, germanium, then tin, and then lead. So what happens is, as I told you, when we move down the group, ionization energy decreases due to increase in atomic size. Okay, because the electrons move away from the nucleus. Now, but if I talk about first ionization energy of lead, it is slightly higher. It should be less than that of tin, but it is slightly higher than that of tin because of the lanthanide contraction. Again, because of the presence of 4f and 5f orbitals, there is a poor shielding, and because of poor shielding, the atomic radii becomes less, means electrons are tightly held by the nucleus. Okay, now atomic size of tin and lead are very close, so charge density is more in the case of lead because of more charge, and electrons are attracted to the nucleus more, and ionization energy is more in case of lead. Okay, so obviously it is going to decrease from silicon to germanium to tin. Okay, decrease over here, it is going to decrease, but for lead it will increase. Okay, that is answer is option 2. Next, tendency of germanium, tin and lead to show +2 oxidation state increases in the sequence. Now, again, if I talk about the tendency of germanium, tin and lead to show +2 oxidation state, it increases when moving from germanium to lead. Okay, now it is because of inert pair effect where ns2 electrons are unable to participate in bonding. So lower oxidation state is stable. Okay, it increases, the stability increases. So +2 is the lower oxidation state, so its stability will increase from germanium to tin to lead. The answer is option number 2. Okay, now next is question number 75. Which of the following does not exist? PbI4, PbF4, CCl4 and CbR4. Now PbI4 does not exist because of the lead iodine bond initially formed during the reaction. It does not release enough energy, okay, to unpair 6s2 electrons and excite them to the higher orbital to have 4 unpaired electrons around lead atom. So there are not sufficient unpaired electrons. Okay, the excitation of electrons does not happen in this case. So PbI4 does not exist. Okay, the answer is option 1. Next is question number 76. Carbon differs from the rest of the members of its group because of. Now you know that carbon is a part of group number 14 elements, but its properties are slightly different from others like silicon, germanium, tin and lead, because firstly it is having a very small size. Okay, not higher electronegativity and ionization enthalpy. Okay, the electronegativity is also not much and ionization enthalpy is also not much. Okay, not high, and there are no d orbitals in the carbon. Okay, so there are no d orbitals in the carbon, because of which it differs from other members of its group. So answer is all of the above. What is the hybridization of carbon atom in CO2 molecule? So in CO2, carbon forms two double bond with the oxygen. So if there are two double bonds, okay, two pi bonds are there. So in that case, students, the carbon is going to be sp hybridized. Okay, so yes, the answer is going to be option number 2. That is, carbon will be having sp hybridization in CO2. Okay, because 2 pi bonds are there. Now question number 78, the correct statement regarding the possible reason for trend of electronegativity in group 13 elements. Okay, now if I talk about the group 13 elements, so atomic size generally increases when we are moving down the group, okay, but not uniformly because the poor shielding effect of D and F electrons. I told you like lengthenite contraction will come up and all of that in heavier elements like gallium, indium and thallium. So this irregularities, it causes variation in effective nuclear charge and electronegativity also, because if atomic size is there is an irregularity in that, there will be regularity in effective nuclear charge and then electronegativity. For example, gallium is smaller, okay, otherwise like boron, aluminium, gallium has to be bigger than aluminium because of the size, because of the increase in number of shell, but because of poor shielding of d electrons, it is smaller in size, and if it is smaller in size, it is more electronegative than aluminium, right? I told you because of poor the electron shielding. So that is why the trends in electronegativity, they are influenced by the discrepancies in the atomic size of the elements, which is option number 2. Okay. Next, which of the following statement is correct regarding group 13 elements? Density increases down the group from boron to gallium and then decreases up to thallium. So actually density of group 13 elements, it increases from boron to thallium only, okay, no decrease, so this is wrong. Okay, boiling point of gallium is very high, which is around 2676 Kelvin. Boron is a soft non-metal, this is wrong. Boron is a hard non-metal. Melting point of gallium is usually low and boiling point is high, so second statement is true. Okay, next is question number 80. So there are some statements given to us students. In thallium, +1 oxidation state is predominant. In thallium, +3 oxidation state is oxidizing in nature. And compounds of group 13 elements in +1 oxidation state are less ionic than that of +3 oxidation state. Okay. So students, if I talk about thallium, yes, +1 oxidation state is predominant because when we are moving down the group, the lower oxidation states, they are more stable. Okay, in thallium again because of the inert pair effect, +3 oxidation state will not be very much stable, +1 will be stable, and +3 oxidation state is oxidizing in nature. This is true. Next, in compounds of group 13, what happens is +1 oxidation state are more ionic than that of +3 oxidation state. So this is wrong. It means only third statement is true. Means only third is incorrect because we had to choose the incorrect statements, no? Next is question number 81. In which of the following arrangements the given sequence is not strictly according to the properties as indicated against it? Okay, so which one is not correct? Okay, so if I talk about H2O, then H2S, H2SC and H2D increasing pK values. So you know, if I am talking about the hydrides, if we are moving from top to bottom, the acidic nature increases. Okay, acidic nature increases. So if the acidity is increasing, the Ka value will also increase and the pKa value will decrease. Okay, for of course for acids the pKa values are lower. So it means the order of pKa value is going to be highest for H2O, then H2S, H2SC and H2DE. It means first one only is wrong. Okay. Next, let's have a look at the other options also, students. So yes, for group 15 hydrides also, the acidic character will increase on moving down the group. So this is true. And for the oxides, the oxidizing power increases again on moving down the group, and here again the acidic strength increases. Okay, so for hydrides, just remember, if we are moving down the group, the acidic strength is going to increase. Next is question number 82. Correct melting point of group 15 elements. So again you can see here the melting point increases up to arsenic and then it decreases up to bismuth. So answer is going to be option 1. It increases from nitrogen to phosphorus to arsenic, then decreases from antimony to bismuth. Okay, next question, students. Question number 83. Covalent and ionic radii of group 15 elements. Now, you know, if we are talking about the atomic or ionic or covalent radii, they will increase down the group. Now, why it will increase down the group? Why? Because of the addition of more shells. Okay. More and more shells are going to be added if we are moving down the group. So, the atomic radii or the ionic or covalent radii is going to increase on moving down the group. See, of course, the atomic size is increasing. A covalent or ionic radius increases from nitrogen to phosphorus to arsenic. Okay, and it increases from antimony to bismuth also, but there is a less increase because of the fully filled D and F orbitals. Okay, D and F subshells. So of course it is increasing, but increasing less. Okay, so the answer is going to be option number 2, that is it increases down the group. Now next question is question number 84. Nitrogen differs from other members of the family because of, now again just like we did for carbon, so it actually differs from other members of the family again because of small size, because it's present in the second period only. Okay, so second period elements, they have small size. Okay, and now it has high ionization enthalpy also. Now why it is having high ionization enthalpy? If you look at the configuration of nitrogen, it's 1s2, 2s2 and 2p3. Now this 2p3 means it is having half filled electronic configuration, and you know that half filled and fully filled electronic configurations are more stable. So because of that, it will be having high ionization enthalpy. More energy is required to remove the electrons from nitrogen because of half filled configuration. And yes, it has non-availability of d orbitals because second period elements don't have d orbitals. So because of non-availability of d orbitals, now below nitrogen we have phosphorus which has empty d orbitals in it. So it means all of the statements are true. Okay. Next is question number 85. Nitrogen does not form pentahalides. Now again the same thing. Now phosphorus can form pentahalides. Okay, nitrogen, phosphorus, arsenic, although their valency is 3. But these elements, phosphorus, arsenic and others, they can form pentahalide. But nitrogen cannot. Why? Because there is no d orbital. Okay, d orbitals are not available. In case of phosphorus, there is empty 3d orbital. So because of that, it can expand its octet. Okay, it can expand its octet and can form pentahalides. PCl5 exists. Okay, but NCl5 does not exist because of the non-availability of d orbitals. Okay, so the answer is option 4. Now let's move on to the section B, which says what are the properties of nitrogen. Now again nitrogen, it forms a triple bond, students. This is true. Nitrogen में triple bond is there. All right. It shows the property of catenation and it has slow boiling point, but it does not show the property of allotropy. So it means 1, 3 and 4 are correct. Okay. It does not exist in different forms, means it is not showing allotropy. Otherwise, all the other properties are there. Next, question number 87. Acidic strength increases in the order HF to HCl to HBr to HI. Statement 2. As the size of the elements increases down the group, the bond strength decreases and the acidic strength increases. So again, the acidic strength depends on two factors, that is electronegativity and bond strength. So of course, if the electronegativity is increasing, the acidic strength will also increase. Okay, but again, if I am talking about the bond strength, longer the bond, weaker it will be, because hydrogen, and if I talk about iodine, so iodine is bigger in size. Okay, if I compare it with fluorine HF bond, so iodine is bigger in size. So if it is bigger in size, the bond length increases and the bond strength is less. Okay, or you can say the bond strength decreases. Means longer the bond, weaker it would be, means less energy would be required to break that bond. Okay, and if we can break this bond easily, means H plus can be released easily, and if H plus can be released easily, what happens is that it will be more acidic. So yes, acidic strength of HI will be more than that of HBr, HCl and HF. Why? Because larger the size of halogen, longer the bond will be formed and the bond strength will decrease, which means it requires less energy for bond dissociation and can be easily broken. So H plus can be released. So it means both the statements are true. Answer is option number 4. Okay. Which of the following is amphoteric oxide? So you know, students, that some metallic oxides, they exhibit the dual behavior. Dual behavior means they can behave as acids also and they can behave as bases also. So those oxides which can behave as acids and bases are called as amphoteric oxides. Okay. So aluminium oxide is an example. Aluminium oxide, zinc oxide, lead oxide, these are the ones that are amphoteric. Keep that in mind. So it means option number 4, which is aluminium oxide, it is going to be amphoteric in nature. Alright. Next, decreasing oxidizing ability of halogens in aqueous solutions down the group is evident from. Now students, the oxidizing ability of halogens in aqueous solutions, it decreases when we are moving from fluorine to your iodine. It is evident from the standard electrode potentials. Okay, we have studied it in electrochemistry also. Ki from the standard electrode potential, we can get to know about the reducing and the oxidizing ability of the halogen. So you know that fluoride ions or fluorine acts as a very strong oxidizing agent. Okay. Alright, so it can act as a very strong oxidizing agent because it has high standard electrode potential value, means it can gain electron very easily. If it can gain electron very easily, so it means it can let the other atom to lose electrons, means it can act as the oxidizing agent. So high reduction potential value for fluorine tells us that. So it means from here I can tell you that the decreasing oxidizing ability, it can be shown with the help of standard electrode potential. Okay. Next question, students. Question number 90. With an increase in molecular weight, the boiling point of halogens increases. Now this is because, now what happens is, because if we are increasing the size of the halogen atom, the bond length increases. Okay. So as the size of the halogens increases, the magnitude of van der Waals force also increases and it will increase the boiling point. So because of the increase in van der Waals force of attraction, okay, it is going to increase in the number of electrons per mole. So that is why the boiling point is also going to increase. Okay. Next question number 91. Which of the following acids is the correct increasing order of their acidic strength. So have seen ki when we are moving down the group from fluorine to iodine, the atomic size increases, and because of that the HX bond length increases, so the acidic strength increases. So from HF then to HCl, HBr and HI, because this HI bond is the one that is easiest to break. Okay, easiest to break means the bond strength is the least because of biggest size of iodine, and because of that the H positive can be liberated very easily. If H positive means the proton can be removed very easily, it will be having more acidic strength. Next, which among the following has the lowest boiling point? We are talking about the noble gases. So helium, neon, argon and krypton. So obviously helium is going to have the lowest boiling point, okay, because it is smallest in size, so it will be having the lowest boiling point of any known substance also, and it has a property of diffusing through most commonly used laboratory materials like rubbers, glass and plastics. Okay, right. Okay, next question. The noble gas exhibits very high ionization enthalpy, which down the group increases, decreases, first increases then decreases, and first decreases then increases. Now what happens is, again, the ionization enthalpy for noble gases is very high because they are already stable. Why? They have a complete octet, right? So if they have a complete octet, so they are pretty stable, and a lot of energy is required to remove the electron from the outermost shell. Okay, but we know that whenever we are moving down the group, the ionization enthalpy or the ionization energy, it decreases. Why? Because the size of the atom is increasing. Because of the increase in number of shells, the outer electrons are moving away from the nucleus, and because of increase in size, nuclear charge decreases, so lesser energy would be required to remove that outermost electron. So it means the ionization enthalpy would decrease when we are moving down the group, be it noble gases also. Which of the following statement is incorrect? Next question. All the noble gases are monoatomic. This is true, students. Now noble gases are monoatomic because they are stable. Their octet is complete. And if the octet is complete, what happens is, you know that they will not bond with any of the other element or with each other. So they exist as single atoms like helium, argon, neon, krypton, okay, xenon, because they are already stable. This is true. Noble gases are colorless, odorless and tasteless. This is true. They are less soluble in water. So again, I think this is incorrect because they are sparingly soluble in water. They have very low melting and boiling points. So this is also true, students. So answer is option number 3. Okay. Question number 95. What is the correct atomic radius order for noble gases? So again, you know, when we are moving down the group, what happens to the atomic size? It increases. Okay, it increases because of the increase in number of shell. So it is going to increase from helium to neon to argon, then krypton, xenon and radon, because again at every period a new shell is being added, and because of that there will be increase in distance of the valence shell from the nucleus, means there will be increase in atomic size. So answer is option A. Next question. Which of the following is correct? F2 has higher dissociation energy than chlorine. Now what happens is the bond dissociation energy of fluorine is less than that of chlorine. Although it is expected that fluorine will be having higher dissociation energy than chlorine because small size is there, okay, bond will be strong and it will require more energy to break. Now what the case is that because of the small size only there is electron repulsions, okay. In chlorine, the electrons p orbitals, but in fluorine, the electrons are in 2p orbitals, which are small in size. So what happens is because of the small size, the repulsion between electrons takes place, and because of the repulsions, the bond becomes weak. The FF bond becomes weak, or you can say weaker than the chlorine-chlorine bond. In chlorine, the electrons are in 3p orbital, so there are no such interelectronic repulsions. So that is why F2 will not have high dissociation energy, okay. Next is fluorine has a higher electron affinity than chlorine. Again, chlorine will be having more electron affinity because of the same reason only, because of the incoming electron. If the fluorine, although it is more electronegative, but the incoming electron, it experiences repulsions because of the small size of fluorine. It experiences repulsion of the electrons present already there, okay. So that is also not true. Chlorine will be having more electron affinity. HF is a stronger acid than HCl. This is also just now we have seen that the acidic strength, it increases when we move down the group. So of course HF is a weaker acid than HCl. This is also wrong. Boiling point increases down the group in halogens. So that is true. Yes, boiling point increases down the group because of more van der Waals interactions. So fourth answer is there. Which of the following has been arranged in order of decreasing bond dissociation energy? We are talking about the bond dissociation energy of phosphorus and oxygen, sulfur and oxygen, and chlorine and oxygen. So you know, students, that the bond dissociation energy is inversely proportional to bond length. Means lesser the bond length, more will be the bond dissociation energy. So if I talk about the bond length, it is based on the electronegation difference also. So phosphorus oxygen bond length would be most, okay, then sulfur oxygen, then chlorine and oxygen. All right, because when we are moving left to right, so that happens. So if phosphorus oxygen bond length is the highest, the bond energy will be least. Then for sulfur and oxygen and chlorine oxygen, bond energy would be the highest. So the answer is option number 4. Next, question number 98. Which set of oxide of nitrogen is paramagnetic? So odd electron molecules like your NO and NO2, they are paramagnetic, students, because they contain one unpaired electron each. So answer is option number 3. Next, correct order for boiling points of group 3 hydrides. Again, students, higher boiling points means higher forces, means more thermal energy is required to separate that particular molecule. So even you know sulfur is more electronegative than selenium or tellurium. So we expect that there would be higher dipole moment, higher attractive forces, okay. More energy is needed because the molecules of hydrides as they get bigger as you move down the group. And oxygen is much more electronegative than the molecules having hydrogen bonding in water, okay. So there will be another order of intermolecular force, so that is why the boiling point of water will be the highest, okay. So the answer is option number 3. Although the boiling point is increasing down the group, but for H2O, the boiling point is the highest because of the hydrogen bonding. This is what we want to say. Which of the following pairs of molecules have almost identical bond dissociation energy? So if you look at the bond dissociation energy, F case of fluorine and iodine, it will be there, students, because just now we have discussed ki fluorine bond mein there will be inter-electronic repulsions. Okay, so there will be electrostatic repulsions, you can say, and the non-bonding electrons of fluorine, they repel each other, and because of those repulsions the bond energy will be comparable to that of iodine bond. Okay, so yes, the answer is going to be option number 3. So students, we have, with that we have completed the video solution for your BPT 14. So I hope all the questions are clear. If any doubt is there, you can still ask us. You can post your doubt in the comment section. Okay, and don't forget to like, share this video and comment as well. Okay, thank you so much, students.